Since observations are affected by random errors and therefore have an associated statistical uncertainty, then the gradient and y-intercept of any determined line of best fit will also have errors. The following procedure details how these can be calculated. In the previous videos, I've shown how to plot a graph and add a trend line, so if you still haven't done it, go back to the videos or go to Level 4 Labs website for instructions. Select the Data tab and click on Data Analysis. Scroll down the list and select Regression, then click OK. Make sure that the flashing cursor is in the window right of Input Y range. Enter the cell addresses for the data plotted along the y-axis of your graph by clicking, holding and dragging the mouse down the column B2 to B6. Now, click in the window to the right of Input X range. Enter the cell addresses for the data plotted along the x-axis of your graph by repeating the previous steps. Under Output Options, click on the circle to the left of Output Range. Make sure that the cursor is flashing in the window to the right of Output Range. Click on the cell A20 in the spreadsheet. This address should now appear in the window. This is where the Regression Analysis results table will appear on the sheet, and click OK. This procedure has produced the formal statistics for the calculation of the line of best fit. Most of the information here is beyond the scope of this introductory workshop. However, you should pay attention to the values of the coefficients, lower and upper 95% for the intercept and x variable. The coefficient of the x variable corresponds to the gradient of the line of best fit, and the lower and upper 95% of the x variable are its corresponding statistical uncertainties, that is, the maximum and minimum values. The same applies to the intercept. To compute the error associated that is quoted after the plus and minus sign with either of the variables, you have to use the worst-case scenario technique. For the data in this example, we therefore have gradient equal to 53.25, lower 95%, that is the minimum value of the gradient and is equal to 48.61. Upper 95%, that is the maximum value of the gradient, equal to 57.89. To calculate the negative error, you always have to subtract the minimum value of the variable from the actual value of the variable. In this case, you have to subtract the lower 95% from the gradient. Therefore, in the cell J29, type minus error, and in the cell next to it, type an equal sign, click on the cell B37 minus sign F37 and hit Enter. To calculate the positive error, you always have to subtract the actual value of the variable from the maximum value of the variable. In this case, you have to subtract the gradient from the upper 95%. Therefore, in the cell J30, type plus error, and in the cell next to it, type an equal sign, click on G37 minus sign, and click on the cell B37 and hit Enter. Larger of these two values is always quoted as the error after the plus and minus sign. Remember to round the error to one or two significant figures and cite the value to the same number of decimal places as the rounded error. In this instance, it should be 53.3 plus and minus 4.6.